Hello, my name is Ethan Zipsel, and this is the 2026 University of Akron Tractive battery video. So let's start with the casing of our battery. So first of all, you can see that the battery has high voltage warning stickers on all faces, and you can see by taking a look around the battery here. Additionally, each face of the battery is labeled with high voltage always energized. And additionally, the team number, car number 14, is located right here on the top of the battery. All right, so as for low voltage and high voltage isolation on our self-developed circuit boards, you can see two of our boards here. These are the only two that have low voltage and high voltage circuits on the same PCB. So really quickly here, you can see that the distance between the gaps is labeled in the silk screen. You can see it exceeds 4 millimeters here at the narrowest point, and then of course it exceeds it once more here at the further point. And then we also have a high voltage discharge board that houses all of our discharge resistors. So you can see the gap here as well exceeds 4 millimeters from the start of the copper heat dissipation pores to the wiring there. And then as for showing the conformal coating, since that distance would require it, you can see in the battery there the reflective glow of the conformal coating. And then likewise, you can see that here on our discharge PCB. All right, so then onto the positive locking here. First thing we can look at here is our IRs. So you can see that we do have nylon patch bolts, which are allowed since it's an OEM component. And additionally, you can see we have other locking points on our fuse and our energy meter. So you can see the tabs here, and you can see the two tabs here and here. And then over here, you can see the last tab on the other side of the fuse. And then in terms of positive locking of the segments, we have Radlock maintenance plugs, which are positive locking. And then we are using custom maintenance plugs that are positively retained by the lid of the battery pressing down on them. For the high voltage path inside of each of our modules, you can see that we have a bus bar running from our cell to the maintenance plug, and you can see that there are 3 thread distorting nuts located right here. As for the low voltage and high voltage wiring, you can see that we are maintaining a gap between our low voltage and high voltage wiring. And additionally, there's barrier material in the heat shrink of the wire itself that we're using. So you can see that at the closer points around the contactors. And for our fuse, you can see that we have our Tractive system fuse here. So this is a 70 amp L70QS fuse by Little Fuse, and that is the same fuse in our ESF. And for the internal section, first thing we can see is that all of the poles of the modules are separated by an insulating barrier. So you can see the Formex in our Tractive battery segment module compartments, and you can also see here on the lid the Formex there above the top of the poles here. And additionally, you can see our Tractive battery fuse located right here. Next, you can also see that there's no always energized Tractive system wire leaving the battery. So you can see that the energy meter pole going here is on the inverter side of the airs, so separated by the IR from the battery. And likewise, you can also see the same is true for this high voltage connector, where you can see that the wires for it are coming from the positive IR there and the energy meter there, both of which are electrically isolated from the battery. Additionally, we have a couple branch circuits here. So first thing you can see is the black fuse on that red wire there. So that's pretty clearly less than 150 millimeters. It's about 30 or so. And then our other unfused branch circuit is here between our two contactors, or sorry, fused within that distance. And then you can also see that the fuses and the IRs are separated by an electrically insulated material. So you can see our Formex on the wall here, and we also have an aluminum barrier and another layer of Formex between that and the lid. And additionally, you can see our module isolation too. So you can see our Formex here on the internals of the wall. And then here with a module removed, you can see that we have another layer of Formex separating each of the modules. So in between each module, there's about 4 layers of Formex. And then looking under here, you can see our temperature sensor attached to the bus bar at the hottest spot of our module. As for the maintenance plugs, we have 2 types that we use in our battery. So we use Radlocks, and then we have custom maintenance plugs made with Molex centrality pins. So first thing is you can see that they can be removed without tools. So I'll pull this off, and then I can remove this. And you can also see that the surfaces are non-conductive except where the electrical conduction needs to happen. You can also see that they are positively locked when they're installed. You know, I can plug this in, and then I can plug this in. Obviously there's a latch here making this positively locking, and then this is retained by the lid of the battery. And additionally, it's not possible to install them incorrectly, so obviously you can't poke these together because of the walls and the gap being too large. And then the only other contact point could be the chance of plugging in these backwards, which is made impossible by the tube here that is holding this in this position. And now for the indicator light section, you can see that our indicator light is located right here on the front face of our battery, labeled high voltage present. It will function when the voltage at the inverter side exceeds 60 volts DC, and you can clearly see that it is functional outside of the vehicle. All of our Tractive system connectors outside of the battery all contain a interlock. So first of all, you can see our interlock pins on our high voltage connector here. So we have two here and here. And then you can see our labeling for our shutdown wires coming into that. And then same thing for the energy meter as well. Our two interlock pins are coming up here and going to our board.